Hello everyone, welcome to this video. In this video, we have to find the sum of the following series up to n terms. Now at first glance, this question looks a little scary, but don't worry, don't be afraid. Let's take out your pens and notebooks and start solving this question. So here, your nth term, it would look something like this: 1 cube plus 2 cube plus so on up to n cube, right? We are going up to n cube. And it is dividing by 1 plus 3 plus 5, and we are going up to 2n minus 1. Why? Because we are taking the odd terms. So if you go up to n terms, so it would be 2n minus 1 for the odd term. Right, now you know what is the sum of cube of first n natural numbers. It is given by this formula: n plus 1 divided by 2 whole square. And you know this forms an odd AP series. AP series with the first term as a, common difference as 2, and we are going up to nth term. In total there are n terms within it: 1, 2, 3 and so on. So this would be your nth term. So the formula for nth term, calculating the sum of nth term, is n by 2, 2a plus n minus 1 times of d, correct? Now you can substitute the value of a and d here. So a is 1, d is 2. We have this expression. Next we can simplify the expression. You can write this expression here like this, and then you can solve this expression. So this 2 could be taken up, right, in the numerator. So it would be like this, n, and here it would be 2 plus n minus 2. So this 2 and 2 gets cancelled. So you are left with 2 divided by 2n square. Correct. So this 2 and this 2 also gets cancelled. So you are left with 1 by n square here. And this n square and n square also gets cancelled. So your an becomes equals to n plus 1 whole square divided by 2. This is your n1. an, correct? And next you can open up the square and separate the terms. So why I am doing so? Because I wanted to calculate the sum Sn, and it would be easier for me if I write the an in terms of separated form. So now we wanted to calculate the sum up to first n terms. So therefore in this case our sum becomes equal to summation ak. Now you can substitute the value of ak. If your an is this, your ak would be k square upon 4 plus k upon 2 plus 1 by 4, substituting n is equal to k into this expression. Okay, now you can separate out the summation onto different terms here like this. Now you can take out 1 by 4 common, 1 by 2 common, 1 by 4 common from each of these terms. So you are left with the sum of square of first n natural numbers, which is n plus 1, 2n plus 1 by 6. Now notice that finally we are substituting the value of n. So here the terms would be in terms of n only and not in k. Similarly here we have to write the sum of first n natural numbers. It is n plus 1 divided by 2, and once we are adding 1 to itself, how many times? N times, total n times. So it would come out to be equal to n. So we are writing n here, correct? Okay, next what you can do, you can take n common from each of these terms, right? And you can take 4 common from each of these terms. This becomes 4 and this becomes 4. So you are left with n plus 1, 2n plus 1 divided by 6. Here you are left with n plus 1, and here you are left with plus 1 only, correct? Now what you can do, you can take the 6 outside by taking the LCM. So you are left with n plus 1, 2n plus 1. You can open this up. It would be 2n square plus 3n plus 1. Here it would be 6 into this expression. So here it would be 6n plus 6 into 2, which is 12. 6n plus 12. Now you can further simplify this. It would be 2n square. The terms containing n, it would be 3n plus 6n, which is 9n, and then 1 plus 12, which is 13. So this is your answer, correct? This is your answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.